All right, here's a screencast for 7.2 part 1. So this first part, we're only going to go these problems, right? We're only doing these problems up here. Oops, did not want to do that. Okay, so exponential functions. I know at least one of the sections, maybe 2, had this lesson, but there are a lot of people gone. It's been a while, so we're going to spread this out over 2 days. Really, with online learning, less is more. Let's just get to it. So, exponential equations. Remember, an exponential literally means growing without bounds. All right, so this is a positive growth, right? It's a growth versus if I have a decay comes down, right? If we're decreasing or increasing. Those are exponential equations. Exponential equations have a positive number as a base and a variable as the exponent. So, b to the x. Normally we write y equals a times b to the x. And that's an exponential equation. Okay, so if we're trying to solve an exponential equation, there's a couple of rules we have to follow. First, you have to let your base be greater than 0. That's important because if I have something like -1 to the power of x, right, -1 times -1 is positive 1. But if I put -1 to the third power, right, times itself 3 times, it's negative. So it keeps switching back and forth, negative to positive, negative to positive. We don't want that to happen. That's why we have to have our base be greater than 0. Now, it can't be 1. If you think about 1 to the x power, it doesn't matter what exponent is, right? To the 1, to the 50, to the 100, right? 1 to the 100 is still going to be 1. 1 to any exponent is just 1, okay? And then, here's the big one. Then b the x equals, if b the y equals b the x, that means the exponents are going to be equal. If you have the same base on both sides, that means you can just set the exponents equal. All right, so 3 to the x, if that's equal to 3 to the 5, you can just set the exponents equal each other and you see x is 5. Awesome. Okay, so to solve an exponential function, write the powers on both sides of the equation in terms of the same base. All right, it has to be in terms of the same base. Recall, a negative exponent is useful when converting a number to its reciprocal. So what do I mean by that one, right? Converting a number to its reciprocal? If I would have something like 3 to the -1, that's the same thing as saying 1 over 3 to the first power, aka 1/3. That's useful, right? Because I can, instead of saying 3 to the -1, I could say 1/3. Or, instead of saying 1/3, I could just say 3 to the -1. Right, if I'm trying to have them be in terms of the same base. So before I come down to the example 1 problems, there's 2 baby problems I want to get through, right? So we're trying to gradually walk into the ocean. I'm not just trying to push you off a cliff, right? That's the idea with these first 2 problems. Next year, I'll probably put these directly in the notes. So if I say something like 3 to the x equals 9, you immediately could be like, oh yeah, you know what? X is equal to 2 because 3 squared is 9. So you already know what the answer should be. But this time, let me rewrite it so that each side is in terms of the same base. So I can write 9 as 3 squared. I'm going to write 9 as 3 squared. Now that I have the same base on both sides, I can take the exponents and set them equal to each other. Awesome. I'm going to try the next one. Okay. Let's say I have 2 to the x plus 1 is equal to 16. I can rewrite 16 as 2 to some power, right? 2 to what power is 16? So 2 to the first is 2. 2 squared is 4, right? So every time we put an extra power, you just multiply by 2. 2 to the third, 8. 2 to the fourth, 16. Okay. So on the left, I still have 2 to the x plus 1. On the right, 16 is equal to 2 to the 4th power. Now that I have the same base, I can set the exponents equal to each other. And remember, we're just trying to solve for x. So just get x by itself. We see x is going to be 3. Perfect. Awesome. One more. Here we go. Let's say I have a problem like 2 to the x plus 1 is equal to 16 to the 4th. Ooh, tricky, right? So we know from the problem we just did, 16 is just going to be 2 to the 4th power, but then I have this pesky to the 4th that I have to leave on the outside. So secretly, right, we're bringing in chapter 5 concepts, right? An exponent to an exponent. How do I combine these? I have an exponent to an exponent, you multiply. So 4 times 4 is 16, so the right side I have 2 to the 16. On the left side, I have 2 to the x plus 1. Since I have the same base on both sides, I can set the exponents equal to each other. And I just solve for x, and I see it's 15. Okay, so here the tough part was we had to rewrite 16 as 2 to the power of 4, and then we have this pesky exponent still on the outside. You have to multiply, right? An exponent to an exponent, you just multiply. All right, now we should be prepared for this one. You can go ahead, pause the video at any time and try these yourself, but I'm just going to go through them. Perfect. So, I know on the left side, 3 to the x. On the right, 9 is 3 squared. We did that before. Ooh, an exponent to an exponent. 2 times 4 is 8. Therefore, x equals 8. And we're good. All right. Ooh, tricky. Okay, so I need to make them have the same base. I can write 4 as 2 squared. Now, multiply these out. Right, distribute out because it's 2 times the 2x minus 1. So I have 2 to the 5x is equal to 2 to the 4x minus 2. Same base, same base. So now we can set the exponents equal to each other. So you should just get -2. All right. Let's see. I'm going to add an extra problem about right here, just so we can get a little more practice. All right, so let's use the reciprocal idea. Okay. Let's have it be, all right, 1/3 to the x power is equal to 9 to the 2x. Ooh, I need to have them both be the same base. And the easiest base to use would be 3. Well, I know 1/3 is just going to be 3 to the -1. So this is 3 to -1 to the x. And I know 9 is just 3 squared, right, to the 2x. Now, okay, so exponent to an exponent, you multiply. So I have -x, 3 to the -x, right? -1 times x is just -x. 3 to the 2 times 2x is 4x. Now that I have the same base, I can set the exponents equal to each other. So 0 equals 5x. Divide by 5 on both sides, I get 0 equals x. Okay. So, not the best idea, but it's all good because, if you put 1/3 to the 0 power, that's 1. 9 to the 2 times 0, okay, well, it's just 9 to the 0, so that's 1. So it checks out. It actually works. All right, we're almost done. Ooh, okay, so this should be an 8. Should be an 8. All right, so using the rule we just said, okay, so instead of saying 1/2, I could just say this is 2 to the power of -1 to the 4x plus 1, and that's going to be equal to, let's say, 2 times 2 is 4 times 2, so okay, 2 to the 3rd is 8, and then I must have the same exponent. Distribute the -1 out on your left side. Distribute the 3 out. So -4x minus 1 equals 2 to the 6x plus 3. Since I have the same base, I can set the exponents equal to each other. All right, plus 4x minus 3. So I have -4 equals 10x. So divide by 10 on both sides. -4/10. Okay, so it's -2/5 is x. -2/5. Perfecto. And the last problem, ideally I'll make these screencasts not be more than 10 minutes or so. All right, so I can have them both be base 9. Yeah, let's chill. Left side, 9 squared equals 9 to the 3x plus 2. And then since they have the same base, set the exponents equal to each other. Solve for x. Oh my gosh. Once again, we find x is 0. Right, there's nothing wrong with that, right? We can literally check. 81 equals 9 to, let's see, 3 times 0, just putting in 0 for x. So is 81 equal to 9 to the 0 plus 2? So 9 squared? Yeah, okay, so we're good. 81 equals 81, so right, this is just checking. And we're good to go. All right, so work on the portion of the homework that is dealing with these. I forget if I put any of these writing exponential functions on the homework for this lesson, but they are heavily in another lesson in chapter 7. So I will see you guys tomorrow.